Hey, we're going to talk about graphing lines, and it's really not that difficult if we have it in slope-intercept form, right? So if I have an equation of y equals mx plus b, you really only need to know about two things to graph this equation: the slope and the y-intercept. That's the y-intercept is where it crosses the y-axis. M is the slope. That's how much it goes up and over. So I'm just going to jump right into it. If I tell you that y is equal to 2x plus 1, to sketch this, it's pretty straightforward. You need a minimum of 2 points for a line, right? If I had a point here and a point here, I could draw a line through it. And I know I missed it, I'm sorry. All I need are 2 points, any 2 points. And we know a line has infinitely many points, so I just need any 2 of them. Well, I can find 2 points with this by using the y-intercept. 1, 2, 3, 1, 2, 3. The y-intercept is 1, and so at y equals 1, I put a point. And then to find another point on the line, I can just use the slope. Now, 2 is a number, but 2 over 1 would give me the form of rise over run. So I can go up to the right one, right? That's up to the right one. Now, from this original point, I could also go, because this is 2 over 1, 2 over 1 is the same as negative 2 over negative 1. And this is what my slope is, right? 2 over 1 is equal to 2, and negative 2 over negative 1 is also equal to 2. So I could, from this y-intercept, go down 2 and to the left 1, down 2 and to the left 1, and still be on the line. Now, my scale is a little bit off, but it should be a straight line. Draw my line. All right, so sketching lines in slope-intercept form is pretty straightforward. Now, there's another example. Let me say, for example, let y equals 3. That is not necessarily slope-intercept form. If I look at this, I don't see a slope. When my y is equal to 3, let me take a look here. 1, 2, 3. Notice that I don't have anything dealing with x. So even if my x was 1, 2, 3, or negative 1, when x is 1, what is my y going to be? 3. When x is 2, what is my y always going to be? 3. When it's 3, what is my y always going to be? 3. When it's negative 1, what is my y always going to be? 3. Since my y will always be 3, that is the equation of a line that is horizontal. Sorry, I missed the points. So this is a horizontal line. It's kind of different from what you would think. Horizontal lines are y equals. All right, that's as opposed to, say, an example like x equals 2, say negative 2. So when x equals 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, when x is equal to negative 2, then it doesn't matter what y is. It could be here. Sorry.
Please come to the main office. Marcus Stewart, please come to the main office.
You would think that I would start over, but I'm not going to. I think we're pretty good here. So again, we have x equals negative 2. When x is negative 2, no matter what y is, I'm still going to have x being negative 2. It doesn't matter what y is. Notice there's no y in here. It doesn't matter. So when you have this kind of line, it's actually a vertical line. So when you have x equals, you have a vertical line. All right, that's when you have x equals something. So graphing lines, not that tough if it's in slope-intercept form. There is such a thing as when you have an example. If you have, for example, y minus 2 is equal to 3 times x plus 1. Well, this is in point-slope form. Point-slope. The point here is given in this form, and you know the slope is given also. There's your slope, 3. Your point is actually this thing, the opposite of this thing, and the opposite of this thing. Because that's a negative 2, your y value would be 2. Because this is a positive 1, your x value would be negative 1. And you can sketch the equation, or you can sketch that graph. At negative 1, 2, you have a point. And then you can go down 3, 1, 2, 3, and to the left 1, 1. And you'll get that line right there. So you can do that from point-slope form as well.